Hi, I'm Ahmad Mirabi. Today I want to share a short sample of my teaching with you. Let's go. Let's talk about Coulomb's law. Coulomb's law is a formula that says what is the force, what is the magnitude of the force when two point charges are close to each other. We know that the point charges, the nature of the force is repulsion if we have like charges, and we have attraction if we have unlike charges. Okay, in this formula, F is equal to K Q1 Q2 over R squared. F is the force between charges. Q1 and Q2 are charges. Here we have put an absolute value, so we are interested in magnitude of the charges only, not the sign, because we want the magnitude of the force only here. R is the distance between charges, so we understand that force is inversely proportional to distance squared. So if the distance between 2 point charges, for example, triples, the force is multiplied by 1 over 9. K is the constant in this formula. It is roughly 9 times 10 to the 9. The unit of K is Newton times meter squared over Coulomb squared. Okay, let's do some examples about the Coulomb's law. Two charges of 2 microcoulomb each placed half meter apart. Calculate the force. We have two charges of 2 microcoulomb each placed half meter apart. Calculate the force. Okay, so we can draw a diagram like this. Positive charge here, positive charge here. They are point charges, and therefore the dimension can be neglected. So we can treat them as a point. The distance between them is half meter. This is Q1 and this is Q2. Both of them are positive 2 microcoulomb. Let's apply the formula. F is equal to K Q1 Q2 over R squared. K was 9 times 10 to the 9. Q1 and Q2 each is 2 times 10 to the negative 6 Coulomb, because each is 2 microcoulomb, so 2 times 10 to the negative 6 squared. And then in the denominator we have half squared. If we simplify this expression, we can rewrite it as 4 times 10 to the negative 12, and in the denominator we'll have 1/4. So here we'll have 9 times 16 times 10 to the negative 3. 9 times 10 is 90, 9 times 6 is 54, so it will be 144 times 10 to the negative 3, or we can write as 144 thousandths of Newton. And the unit of force is, of course, Newton. So this is the force applies between these same charges. Of course, the direction of the force is repulsion, so we can show force like this. This is the force object 2 applies on object 1, and this is the force object 1 applies to object 2. So just like what we learned in Newton's third law, which is reaction and which is action and reaction forces. If Q2 applies this force to Q1, Q1 applies this force to Q2. So the direction of the force is like this. And the magnitude, we calculated the magnitude. Okay, another problem. Two like charges Q each placed 30 centimeters apart, exert a repulsive force of 10 Newton to each other. Calculate the charge Q. So again, we need to apply the Coulomb's law formula. F is equal to K Q1 Q2 over R squared. The force is given to be 10, and K is known to be 9 times 10 to the 9. Okay, Q is unknown. The distance between the charges are 30 centimeter, so converting it to meter, it is 0.3 squared. Therefore, the only thing unknown here is Q here. 10 equals 9 times 10 to the 9 times Q squared over 0.09. 9 can be crossed away here, and it will be 10 to the, so 10 is equal to 10 to the 11 times Q squared. So Q squared will be 10 to the negative 10. And therefore, Q is 10 to the negative 5 Coulomb. As I said, Coulomb is a very large unit, so we usually tend to express the charges in terms of microcoulomb or nanocoulomb. Microcoulomb is closer here, so we can say it is 10 microcoulomb. The charge of Q, the charge of each object is 10 microcoulomb. Okay. Calculate the charge Q. We found the charge of each object. This is the last example in this session. If the distance between 2 point charges doubles, how does the electric force change? As we learned, the force is reversely proportional to distance squared. So if the distance doubles, the force will be 1/4. So we can show it like this. F2 over F1 will be 1/4. So the force will be 1/4 of what it was initially. Another way to show this result is like this. F2 over F1 is, first you have this formula, and then let me change the R. First we have this formula K Q1 Q2 over R squared. The charges remain the same. K is the same thing, but the distance is being doubled. If the distance between two charges is doubled, so here is the distance in the second case. So now everything cancels away. K cancels, Q1 and Q2 are the same. R is the same, but here we have 2R, so the result is 1/4.